How RAG technology changes the way we work with large language models. Have you ever faced a situation like this? You ask ChatGPT something simple and straightforward, and the answer is complete nonsense, but it looks legit. Hi, I'm Gregory, your MLOps navigator, and for the past 3 years I've been helping my clients to implement generative AI in their business process. And you know what I've noticed? The biggest problem of modern large language models is that they often provide you with facts that don't exist. According to Stanford AI, ChatGPT responses contain factual errors in every third answer. And this leads to a leap in confidence that causes companies to slow down adoption of AI. McKinsey recently reported that 57% of their clients consider this problem as the major factor stopping them from going all in with AI, especially when it comes to the most valuable business processes. That's why for professionals working with large language models, it's a major issue that goes far beyond theoretical discussions. Hallucinations is the most common and precise term that describes this phenomenon. That's when the model is confidently generating factually inconsistent information, like citations of non-existent research papers or alternative historical facts. I remember when I first faced it after GPT-3 got published. I was working on a project using a specific coding framework, and I was trying to add some functionality that was not supported by it. After several hours of searching over the internet, I asked ChatGPT and it provided me with an answer that looked elegant and simple. That's just the way I was expecting it to work. That was cool. There was one problem. It didn't work. What GPT actually did is that it simply translated my text prompt into the code that looked legitimate in the context of the framework, and that's it. It didn't know how the framework actually works, which features does it provide, and how they are supposed to be used. When you are generating a cool-looking essay or working on a sci-fi novel, this might look funny, but in medicine, finance, or legal, this is unacceptable. You can't automate your business processes that affect your life, money, or security using a tool which is that noisy. So this is where the RAG, or Retrieval-Augmented Generation, comes onto the scene. In the traditional approach for a large language text generation, that would be pretty straightforward. You ask a question and the model uses its weight, which actually represents the knowledge it obtained during training, to generate you the answer. But these weights can be inaccurate, outdated, or incomplete. RAG approaches differently. There are two main steps. The first one is retrieval and search, and second is generation. So when a user asks a question, the system first searches the external database and finds the relevant pieces of information, then adds them to the system prompt, and after that sends the whole prompt to the model along with the original question. This approach forces a model to answer not only using its internal memory, but also using relevant up-to-date facts. Any RAG system has the following components. First one is the data storage. This is a database of documents used to form the context. This context could be documents, research papers, internal database, any information you like, even your client internal data. Second is the index. The input data storage is split into smaller chunks and passed through an embedding model, the model that is used to translate the meaning of these chunks into a format that machines can understand, which is numbers. Third one is the search engine. The search engine transforms the user query into the same language used by the index and finds which chunks are the most relevant given the user query. It takes a system prompt consisting of the user query and the relevant chunks combined and generates the final answer. And voila, this approach drastically increases reliability of the LLM answers. Financial institutions can now create AI applications that help their relationship managers to analyze how they help their clients to grow their business or manage risks. Medical clinics can now use Gen AI to help doctors to analyze patients' symptoms or suggest treatment. Researchers can now analyze vast amount of research data, opening the path to new discoveries. And these are not experiments, these are real-world cases that exist today. Advantages. It's hard to underestimate the advantages that you get when using RAG. The first one, of course, is the factual correctness. The system works with the sources, internal or external, that you trust. The second one is relevance. The system works with up-to-date information with the cutoff date defined by you, not by the model training date. And finally, the transparency. The system is able to provide you with citations to support the claims it's making. Hands-on. Now let's move to the funniest part. Let's create a simple RAG system. Here's a list of components that I chose to start with. Well, I have to mention that it's a rapidly changing ecosystem, and every day there are new tools that come onto the market. You do not need to learn how to use them today by heart. Just try to understand the main concept so that when you face this problem and you have to build your own RAG system, you know which elements you need to succeed. Here are the main components that we are going to use for this demo. The first one is the LangChain. We're going to use LangChain to orchestrate all the components. This is the most popular and common package used today on the market. Second one is the face. It is a vector storage, and I chose it because it's in memory. For production cases, I would really suggest you using something more serious like Pinecone or Neo4j. And finally, we'll be using OpenAI API to obtain embeddings and to generate the answers. In fact, you can use any LLM available on the market today: OpenAI, Claude, Gemini, DeepSeek, etc. So let's move to the funniest part. Let's implement a RAG system by itself. In this example, we are going to use RAG to teach an LLM to answer about 5 biggest tech companies: Amazon, Google, Apple, Tesla, and Microsoft. I store them in the documents folder of the project. But before we start writing any code, we're gonna need to install the dependencies. Let's start by installing dependencies. We will need LangChain itself, LangChain OpenAI to ensure that we can use OpenAI API inside the LangChain, and LangChain community, which is a package which is developed by the LangChain community and contains a handful of different classes and tools that we're going to use throughout this tutorial. Next, we're going to use python.env package to be able to securely store and retrieve API components without necessity to commit them inside the code. And the face CPU package, that is a package that will allow us to create the vector store. So you can install them using pip install or any other dependency management software that you are using. Then once we have installed them, we will need to import them. We will need some standard libraries like glob, JSON, OS, and typing any for type annotations. We will need to load the load.env function that will allow us to read our credentials from the env files. And then we have a handful of LangChain imports. If you want, just take a pause and copy them for yourself. And of course, the link to the notebook will be available in the description. And the final step that we're going to need is to set up some constants. So we'll need to load OpenAI key from the .env file. If you don't have an OpenAI key, it's super easy to get. Just go to openai.com API sections and create a token for yourself. Then we're gonna specify with the path to the folder that contains the documents that we're gonna use for the RAG. Then we've got the chunking parameters, which is the chunk size and the chunk overlap. I'll talk about them later. And we'll specify which embedding model and which LLM model we're going to use. These are just string constants that will supply to LangGraph. So for loading, we're going to be using something very simple. Basically, we'll iterate we will find all the txt files located in the documents folder, and then using the LangChain text loader, we will load this every single document. And then we'll also add some metadata for each of these documents. Metadata represents some information that is not directly the content, but rather the context of a file that is used for the RAG. So as you can see, we were able to load 15 files, 3 files per company. An example of the document metadata will look something like this. Here's the name of the file, here's the company, and some preview of this file. Okay, now that we've loaded the documents, we need to split them into smaller pieces. Why do we need to do that? That's very simple. In general, a single news item can be pretty large. Therefore, we will need to split it into smaller pieces. But when doing so, we need to make sure that we keep some artifacts and restore connections between the chunks. That's where we add chunk overlap part to the system. Chunk size and chunk overlap are the 2 hyperparameters that you would want to play with when you are tuning your RAG system. The shorter the chunks, the smaller and more specialized chunks you're gonna get, and the bigger the chunk overlap will affect the number of chunks that will be generated out of your doc data. So in order to chunk the documents, we'll be using chunk documents function, which receives a list of documents and the parameters that will be used to create these chunks. So we'll be using recursive character text splitter, which is the splitter available in the LangChain community. We will pass it with the chunking parameters, and we'll also specify the patterns that are going to be used to create these chunks. Because it's a text splitter, you can say stop at 1000 symbol, or you can say stop when you reach closest to the 1000 symbol, but for example, don't split the words by half. And this is what we're doing here when specifying the separators. So in order to create the chunks, we will call the method split documents and pass it the list of the documents that we loaded at the previous stage. And as in many cases, don't forget about the metadata that you want to associate with each chunk, because once the chunk is split, you need to store some metadata that will point to the original source that the chunk has been created. So in our case, we will be adding chunk ID, chunk size, and the total number of chunks. So let's print some stats and see what we have. So we split our 15 documents into 80 chunks. Each chunk is something between 145 and 997 characters. And different companies produce different number of chunks. That's because the difference in the length of the in-use items. And each chunk example will look something like this. So it will have some chunk text as well as the metadata that inherited partially from the documents and was added during the chunking part. So when we talk about vectorization, this is very simple. Embeddings is a numerical vector that represents the meaning of the phrase. So imagine if you lived in the world where every single word could be characterized only by 3 dimensions, how royal it is, how feminine it is, and how masculine it is. The word queen would be something that has high royalty and high femininity. But the king in this case would be characterized by embedding 1 for royalty and 1 for masculinity. And finally, the phrase, the queen is dead, long live the king, will have the embedding of 110. I oversimplified this example just to get the understanding what the actual embeddings mean, but in the real world, LLMs will have hundreds or even thousands of dimensions describing each word. So for the sake of this tutorial, we'll be using OpenAI embeddings. We will need to pass the name of the embedding model and the API key that we want to use, and then call the method embed query and pass it the text and receive the output. So for example, if we pass a machine learning is a subset of artificial intelligence, we can pass it to the text embedding 3, the small version of it, and then we'll have a vector which will have 1537 dimensions, and these are numbers that really probably won't tell you much unless you're a very niche specialist in this area. So let's create a function that will create embeddings for the different chunks. So in this case, we'll take page content of each chunk and create embeddings the way I described above by calling the embed documents, and we'll return a list of embeddings for each chunk. Now we have all the components to create our vector database. The vector database in general will have 2 main components, which is the text of an item, in our case it's a chunk, and a vector representation that will be used to search for this text. This architecture allows to create a very fast searching mechanism, because searching numbers is much faster and more efficient than searching textual data. So for this, we'll be using the create_face vector store, which will take a list of documents and the embedding model. So in order to create the vector database, we're gonna need the list of content of each page, and we'll also need to provide it with the list of metadata. And turning these page contents into embeddings will be handled by Face automatically. So we'll need to supply it with the embedding model that we want to use for this one. So if we take a look at this, we created a vector store consisting of 80 documents. It has 80 vectors, and each vector has the same dimension that we described before. Now that we've created the vector store, we can simply send queries to this database and say what are the closest chunks that correspond to the user query. So for example, if we ask about what is the latest news about Amazon, what we will need to call a method which is called similarity search with score. We'll provide it the text of our question, and we'll say that we want no more than 2 items to be fetched for us. And if we look at this, in our case, it found 2 documents. The first one is a news article saying the next tablet might run on Android, and the second chunk is the chunk from the same document. It found us 2 chunks, but in terms of similarity, these are the closest ones to the question about what is the latest news about Amazon. So now we are ready to create a reg retriever class. Responsibility of the reg retriever will be to find the chunks that are relevant to a user query and format them so that they can be injected into the system prompt. We'll have a method retrieve documents that will accept a user query and that will do the similarity search in the vector store. Well, the similarity search with vector store returns us both the score and the data, but for this text context for a user query, these numbers might confuse. So we're going to need a simpler method that will only return the document content that are relevant to the user query. That's why I have get documents. Then we have the final method, which is the get context string. This method is very straightforward. It will get the documents, and then for each of the documents, it will form some text representation of this context part, and then join them all together. So let's test how this works. We are instantiating a reg retriever, saying that we want no more than 3 items based on the vector store. And then we're passing it 2 test queries. The first one, what is the latest news about Amazon? And also let's pass it some text that we definitely know that it does not exist in the document database that we'll be using. And let's see what it gives us. So in our case, for the question about the latest news about Amazon, it was able to retrieve 3 documents. Each one has a pretty decent similarity, below 1, 2 chunks from the same news items that we saw before, and also we have one about live AI shops. Whereas for the question about machine learning, we still retrieved the 3 documents, but we can see that the score is even higher. Well, let's talk about the scores. In general, the score of 0 means that there is an exact match between the user query and the chunk data, which is a very rare and exotic situation. Basically, the rule of thumb says that everything below 1 is a very good match. Everything above 1 to 2, it means that there is some semantical overlap between the user query and the text. For example, they both talk about AI, or they both talk about automobiles or anything else. But similarity above 2 means that the user query and the chunk text do not overlap with each other, and you probably should not use them. But it's worth mentioning that the similarity threshold that you will use to remove irrelevant chunks from the context is a hyperparameter. You need to test it out with different prompts and see which exact cutoff threshold will be working best for you. Now we're ready to generate the reg prompt. Let's take a look at the system template, which is the instruction that we are gonna give to an LLM, which will not depend on the user query. So we're saying that you are a helpful AI assistant that answers questions based on the provided context. Your task is to analyze provided context carefully, answer the user question using the information from the context, be accurate and cite your sources when possible. If the context does not contain enough information, say so clearly, and if you're unsure about something, acknowledge the uncertainty. And then we have put a placeholder for the context that will be retrieved based on the user query. Second part of the system prompt will be the human template, which is straightforward. A placeholder for the question, and then we provide an ask to the model to provide a detailed answer based on the context above. So the generate reg prompt will be a very straightforward function. It will take a string question and the reg retriever that we're going to use, and it will create a chat prompt template, which is the template for any chat template inside the LangChain, where we can define different messages that are sent to the LangChain model. And in our case, we'll provide the system template as a system message and the human template as a human one. Now that we have the question, we can get the context string that is relevant for the given question and also update it in the chat template. So if we run this part now on a simple question, how long will the latest Apple Watch battery last? We're gonna get a system prompt that contains the instruction that we just gave to the model. It will contain the context information and will contain the human part. So everything is working as we wanted. Okay, we're almost there. By the way, if you made it to that point, please subscribe. That's an easy thing for you, but it's something that will really keep me motivated for doing other videos. Okay, so now we are ready to create a generate answer function. This will be the function that will collect all the pieces we've built so far into one place. So basically this function will take a question, will take an LLM model, and will take the retriever, which is the class that we created above. First, given a user prompt and the retriever, we can generate a RAG prompt. We can add the question to this prompt and invoke the LLM with the formatted message. Once we have it, we can now return a dictionary that will contain the original question, the response, as well as the citations for the sources. Let's add the file, company, and the similarity score. So as previously, let's start it with two questions, one which is relevant and second one which is irrelevant to the documents that we have. The first one will be what is the latest news about Apple, and the second one will be how do I learn machine learning, and see what the system gives us. So for the question one, we get that the answer contains all information about iPhone 17, iPhone Air, Apple Watch series, AirPods Pro, etc. So we can see that the system was clearly able to identify the latest news about Apple product. And for the second question, how do I learn machine learning? The system says the provided context does not contain any information about learning machine learning. Well, which is actually true. So we've achieved the result that we wanted to get. Let's do one more try. Let's send the same two questions to the system without RAG and see what would be the answers provided by raw LLMs. So the first one about Apple, we can see that at first it says it has a knowledge update on October 2023 and it cannot provide us with the real-time data, but it provides some general knowledge about iPhone 15, something iOS 17, etc., which is really something outdated, which is like more than 2 years ago. And about machine learning, the system provides us a very generic roadmap for learning how to create machine learning models. As I said before, the tools I'm showing you will probably get obsolete in the next couple of years, but the main approach will remain the same. Even today, there is a handful of tools available for scaling this system. For example, you can add support for different chunking options. Code and images should be transformed differently from the simple text. Or you can add support for more advanced vector search database. Or for example, you can add support for knowledge graph generation your documents contain. Or even turn this whole system into a multi-agentic application that use more specialized agents that will use large language models to retrieve, challenge, cross-check information before it is being sent to the... And of course, don't forget about the computation time optimization. Different chunks can be processed in parallel, faster models can be used, more optimal solutions for caching can be applied as well, etc., etc. Always remember that your primary goal is to understand how the system has been built and how it works under the hood. So let's wrap it up. RAG is not a technological improvement, it's a fundamental shift in the approach in how you use large language models. It solves one of the most crucial problems, unreliable data. But implementing RAG will require careful planning. You will need to choose the relevant and reliable sources, decide how and when these sources will get updated. You will need to choose and fine-tune the hyperparameters. But in exchange, what you will get is a significant improvement of the quality and reliability of the answers that you get from LLM. So, what to do next? Start with an experiment. Collect a set of documents and create a simple RAG application using this template. Test it and check the results with raw LLM outputs. And of course, share your results and comments. And remember, in the model AI-driven world, the advantage does not belong to people with the highest computational power or data, but it belongs to people that can use this data in the right way. Stay tuned and see you later.